Bismillahirrahmanirrahim. Dear students, grade 12, and this is lecture number 58, and we are discussing chapter number 20, chemistry, second year. So in the last lecture, we completed the carboxylic acid different formulas which contain one carboxylic acid group or two carboxylic acid groups, and we also discussed the formulas of those acids. Now, according to your reduced syllabus, now we done the nomenclature, physical properties, structure, and now acidity. In the structure of the carboxylic acid is a planar and consistent of sp2 hybridization. There is a sp2 hybridization in the carboxylic acids, and the resonance interaction of the lone pair of hydroxyl ion with the pi system of the carbonyl group. Carboxylic acid is a weak acid. Carboxylic acid is a weak acid. So its pK value approximately 5. Its pK value is approximately 5, but they are only weak as compared to the hydrochloric acid and sulfuric acid, because they have very low value of pKa. If you are going to compare the different acids, ethanoic acid, which has a pK value 4.7, formic acid, the value of pK is about greater than that of the 4.7, propanoic acid 4.9, fluoroethanoic acid. When you are going to introduce a halogen atom with the carboxylic acid, fluorine atom, so its pK value is going to be decline. And if the instead of the alkyl group you are putting the hydrogen, again the pK value is going to be reduced. That's why formic acid has a less pK value than that of 4.7. Chloroethanoic acid, because fluorine is more electronegative than chlorine, so if you add one chlorine with the ethanoic acid, then 2.9, and if two chlorines is going to be added, because one chlorine more hydrogen is going to be replaced, so 1.3, and if you are going to add the 3 chlorine, so it is more reduced. It will be more reduced, just like this. Trichloroethanoic acid. So there is no hydrogen, and the value of pK for the trichloroethanoic acid is only 0.9. Nitroethanoic acid, if you are going to put nitro group with a carbon, then 1.7. Resonance stabilization we done in the previous chapter that carboxylic acids are more acidic than alcohols as well as phenols. Resonance stabilization of carboxylic acids allow to negative charge to be delocalized between the two electronegative oxygen atoms. We done the structures in the previous chapters. So addition alcohol, I told you, the very weak acids, the pK value is approximately 16. So very weak. So because of value of pK is very high indeed, 16, and the carboxylic acid has a 5. So you can compare this one. So adding electron with the drying substituent increases the acidity by further stabilizing the carboxylate ions. We done in the previous chapter in the phenol comparison of the acidity of alcohol and phenol and carboxylic acid, and this stability by adjusting electron with the drying substituents. Now students, there are methods for the preparation of carboxylic acids. Methods for preparation. How we prepare. Methods for preparation of carboxylic acid. Methods for the preparation of carboxylic acid. You done in the previous alkyl halides. This is the same repetition is here from the carbon dioxide gas. When you use carbon dioxide gas by using a Grignard's reagent, Grignard reagent is alkyl magnesium halide. So when you are using the Grignard reagent methyl magnesium bromide, partial negative charge, partial positive charge, partial negative charge. This is the organometallic compound, very important organometallic compound. Victor Grignard, he got Nobel Prize for this. So this is a Grignard methyl magnesium bromide and carbon dioxide gas. This is the carbon dioxide gas in the presence of dry ether. So in the Grignard agent, this alkyl is a nucleophile and this carbon is an electrophile. So the nucleophile must attack to the electrophile carbon center. So what happens? This oxygen is same, no change, and here the alkyl group is going to be attacked. So the double bond of this oxygen changes into single bond oxygen, and the remaining part magnesium bromide is going to be also attached. So this is the intermediate product. So when this intermediate product is going to be we call upon acid hydrolysis. Acid hydrolysis means you have to remove one hydrogen from here. It will be like in this form. These hydrogen ions, proton. So these protons are going to be react with oxygen, combined with oxygen to make a carboxylic acid functional group. So this is the alkyl group, carbon, double bond oxygen, there is oxygen, and this proton is connected with oxygen. This is ethanoic acid. Ethanoic acid plus magnesium hydroxy bromide. So this is the ethanoic acid preparation from the Grignard's reagent using the organometallic compound alkyl magnesium halide. So this is the methyl magnesium bromide, methyl with partial negative, magnesium partial positive, bromide partial negative. This is the carbon dioxide gas, partial negative, partial positive, partial negative, dry ether. So this methyl is going to be attached this carbon here. So you are seeing this carbon is attached with the alkyl group here. This bond is not going to be changed, and the double bond change is single bond. Remaining part is going to be attached here. So this is the intermediate product. This intermediate product by the followed by the acid hydrolysis. So this proton is going to be attacked to give a carboxylic acid. So this is first method. By using Grignard's reagent, the reaction is carried out by passing carbon dioxide gas through the ether solution. I told you the ether as a solvent we use. Corresponding Grignard's reagent by adding Grignard's reagent to crushed dry ice suspended in ether. Carbon dioxide gas must be in the solid form. Solid form. That's why you say dry ice. Carbon dioxide gas about minus 80 degrees centigrade. It is going to be changed into solidified. We call dry ice. So the addition product on reaction with the mineral acid produces carboxylic acid. Second method is hydrolysis of nitrites. Hydrolysis of nitrites. Number 2. Hydrolysis of nitrites. So when you are going to, nitrites are prepared from the alkyl halide and sodium cyanide. Alkyl halide means you have methyl or ethyl chloride with sodium cyanide. Like this one. This is a sodium cyanide and you will get a methyl nitrite. So from this alkyl nitrite, methyl nitrite, we are going to prepare the carboxylic acid. So this is the methyl nitrite and upon the acid hydrolysis, heat, you will get carboxylic acid. You will get carboxylic acid in this case. Compounds having cyanides group are called nitrites. Hydrolysis on the alkane nitrites boiling with a mineral acid, I told you with the presence of acid, so you will get the carboxylic acids. Then oxidation of primary alcohols. You done this review is given here. This in the chapter of alcohols, you done this. So primary alcohols, ethanol. This is number 3rd. This is a review. Ethanol, catalytic oxidation by using a nascent oxygen. Nascent oxygen is prepared from potassium dichromate and concentrated sulfuric acid. So there the dehydration taking place and you will get aldehyde. This is the acetaldehyde and plus water. So this oxidation is a continue. So same conditions. So you will get carboxylic acid. This is the carboxylic acid is prepared from the catalytic oxidation of alcohols, intermediate aldehydes, then you will get the carboxylic acids. Now directly you can use the mild oxidizing agents just like Nels reagent, Fallon's solution, Tollens reagent, and potassium dichromate, sulfuric acid with a dilute nitric acid, as we done in the previous lecture, that these aldehydes can be converted into carboxylic acid. Direct aldehydes can be converted into this. So you have also, if the aromatic compound is a toluene, nascent oxygen, same condition. So you will get benzoic acid. This is a benzoic acid. Toluene changes into benzoic acid. So this is again carboxylic acid functional group is going to be formed here. So in your also reduced syllabus, hydrolysis of nitrites, oxidation of primary alcohols review done, and oxidation of alkyl benzene also we done in the previous chapters. This is also review. So these are the methods for the preparation of carboxylic acid. Now reactivity. Reactivity of the carboxylic acid. These are the methods. Reactivity of carboxylic acids. So dear students, carboxylic acid have two groups. This is a one carbonyl group, and there is a oxygen with hydrogen, and alkyl group is here. So you are seeing there are two functional groups are present in the carboxylic acid. So the carboxylic acid will give two kinds of chemical reactions. In one reaction, the carbonyl group is going to be involved here. Means there is a breaking of bond between the carbon and oxygen. Means this OH is going to be removed. So you will get like this one, OH removed. I will explain. Number one. Number second chance is that the breaking of oxygen and hydrogen. So here OH means carbon, oxygen bond break, and OH is going to be hydroxyl group is separated. And other is that this oxygen and hydrogen bond is going to be broken down, and you will get the proton. So there are two we have here types of chemical reactions. Now I am going to write here. Reactions of carboxylic acid 20.7, conversion of carboxylic acid with its derivatives, derived compounds. Carboxylic acid undergo the following types of chemical reactions. Already I had told you. One is the reaction in which the hydrogen atom of carboxylic acid is involved. there is a salt formation. Second, the reaction in which the whole OH group is going to be replaced by another group. And third, complete carboxylic acid group is going to be involved. Whole group COOH is going to be involved. So dear students, if you are going to see the iodization of the acid, it is weak acid. This is the one case. There is a breaking of the oxygen and hydrogen bond. You will get carboxylate ion, ethanoate ion or carboxylate ion with proton. So this is the one case. In this case, you will get the acid-base reactions. Acid-base reactions. Neutralization reactions. Sodium acetate or sodium ethylate form and water. So here the hydrogen is removed and nitrogen is going to be added. So this is called sodium ethanoate or sodium acetate. Sodium ethanoate or sodium acetate, same chemical reaction you will get when you are going to react the carboxylic acid with sodium carbonate or sodium bicarbonate. So you will get again the salt, same carbon dioxide gas plus water. So this is the reaction where the only oxygen and hydrogen bond is going to be broken down. It can react with also sodium independently. Plus sodium added. Sodium acetate plus hydrogen gas. This is the same. You can see the hydrogen is removed, hydrogen is removed, hydrogen is removed. So they like this one. So these are the reactions in which the carboxylic acid, the salt formation, the hydrogen and oxygen bond is going to be broken down. Now, these chemical reactions now, where the whole OH group is going to be involved. This is the involvement of only the bond is the hydrogen and oxygen bond. In between oxygen and hydrogen bond broken down. And if you see all the products. Now OH group whole, hydroxyl group is going to be involved. Involvement of hydroxyl group of the carboxylic acid. The addition of nucleophile to the carbonyl group is always followed by the displacement of the hydroxyl group by some other group producing carboxylic acid derivatives we called. The hydroxyl group can thus be replaced by the halogen, or we can use the alkoxide O, or by the amine. So in this case we make the alkyl halides, we make esters, or we get amine respectively. So there is one chemical reaction where the OH group is going to be involved of the carboxylic acid chloride in the presence of pyridine. This is a pyridine. In the presence of pyridine, so this group is going to be like this one. So here the OH is going to be evolved from here. So whole OH group is going to be removed from here. So in this case, you will get here now this chlorine. So you will get acid chloride in this case, acid chloride and sulfur, oxygen, and HCl. So this is the acid. Acid chloride, sulfur dioxide gas and the hydrochloric acid. So this oxygen carbon bond breaks, means OH is going to be displaced. So this is the one reaction. Second reaction is that preparation of acid and hydrides. Acid and hydride. Two molecules of carboxylic acid involved in this case. Phosphorus pentoxide acts as a dehydrating agent. So in this case, one molecule involve OH group, other molecule involve oxygen and hydrogen group, both. So in this case, water is going to be removed and you will form acetic anhydride. So in this case, CH3, CO and oxygen is there, like this one. And in this case, the CO and CH3. This is the acid and hydride. This is the acid and hydride by the removal of water. You can write in this form also. Same. This is also acid and hydride. Then there is a preparation of esters. When the carboxylic acid are heated with alcohols, presence of concentrated sulfuric acid, there is a esterification, esters. This is another reaction where the hydroxyl group is involved here and the oxygen and hydrogen group are involved to make the acid and hydrides. Now esterification. In the esterification, you have carboxylic acid and plus ethanol, alcohol, mineral acid. So this is the ethanol and this is the carboxylic acid. So here again this OH is going to be removed from the carboxylic acid, and here the hydrogen. This hydrogen is going to be removed to make a water, and this is called alkoxide. Ethoxide is going to be attached. So you will get CH3. This is the carboxylic acid portion. This is from the carboxylic acid, and this is the alcohol portion. I am going to separate it. So this is the ester. Ethyl, methyl, ester. Ethyl ester, methyl ester, or ethyl acetate. Ethyl acetate or ethyl ethanoate. You can remember all the names. Ethyl, this is the ethyl group, 2 carbon, methyl 1 carbon, methyl, this is the ester functional group, and ethyl, this ethyl, and this whole is acetate, ethyl acetate, and again this is the ethyl, and this is the ethanoate radical. So these are the esters, and they are using for the artificial flavors. So this is a Fissure esterification. These reactions are called Fissure esterifications. Esters can also be made by the carboxylic acid derivative, especially already I prepared the compound acid chlorides and anhydride by reacting with the appropriate alcohol's presence of weak base. So dear students, here the reactivity of the carboxylic acid, reaction of alcohol decarboxylation, reaction of carboxylic acid with derivatives means alkyl hydrides. Reaction of carboxylic acid derivatives acyl halides, alkyl halides. So acyl halide, thiolide, chlorides. This is the article number 20.74. Acyl halides. Summary of the reactions. These are the interconversions. Dear students, there is a very important thing here. Acyl halides are the most reactive of the carboxylic acid. Acyl halide. Then acetic anhydride, ester, amides, carboxylic acid. So this is what distinguishes from the aldehydes and ketone. They can all be prepared from the parent carboxylic acid. The chemical reactions are given under both. So if you see the reactivity order on the page number 243 down, acyl chloride are the most reactive. The reactivity is going to be decreased, then anhydride, then ester and carboxylic acid, same reactivity, and then amides, and the last carboxylate ion. Acyl chlorides are the most reactive class of organic compound. Then anhydride, ester and carboxylic acid are same, then amide, then carboxylate. So there are 4 types of carboxylic acid derivatives. These are the esters, amide, acid halides, and acid anhydrides. So acid derivatives are generally obtained by carboxylic acid by the reaction of nucleophile, and chemical reactions are given here. So first chemical reaction is reaction of acid halides with carboxylic acid. Production of reaction you done in the previous alkyl halide, acylation and alkylation. I think 2 times I will revise this, no need for this. The reaction of carboxylic acid with acid chloride. This is the acid chloride already we prepared in the previous reaction, and reaction with the carboxylic acid. This is a carboxylic acid. And followed by the solvent pyridine. This is the pyridine. So you will get the anhydride. like this. Oxidant. Anhydride. Acid and hydride. This is acid and hydride. First reaction, then acid chloride, which is a more reactive. That's why you can prepare other also carboxylic acid reaction with alcohol in the presence of sulfuric acid. So again, you will get ester. This is the same ester, ethyl ester, and again you will get HCl. So this is the ester, ethyl ester. Previous I wrote this one. And number 4, hydrolysis. Hydrolysis followed by acid. So you will get a carboxylic acid and plus HCl. So carboxylic acid is going to be prepared from the acid chloride, most reactive compound. And the last one is again acid chloride plus ammonia. You will get amide. This is the amide, acid amide, and plus HCl. This compound is called acid amide. So these are the 4 derivatives derived. This acid chloride is derived from carboxylic acid. You done the previous reaction for the preparation that carboxylic acid is going to be formed by, it's going to react with hydrolyzed chloride to give acid chloride, most reactive. Then there is a carboxylic acid, you will get the acid anhydride, acid chloride alcohol to give ester, acid chloride water to give carboxylic acid, acid chloride ammonia to give acid amide. So dear students, here we are going to finish this lecture. We completed here. Inshallah, next time these reactions of carboxylic esters, we finish this. Yes, reactions are finished. Chapter is finished. Okay, next time we will see the chemical reactions are finished here. Thank you very much. Inshallah, next lecture we will meet.